Hey you guys, it's Nina. We're gonna talk about solving quadratic equations by factoring. This is section 3.4 or 3-4. So I'm going to go a little bit out of order, and rather than starting with the vocabulary, I'm just going to show you this example first, and then we'll fill in those blanks for vocabulary. So um, this is what's called a quadratic equation. It's quadratic because it has x squared. This is in standard form. When you split the quadratic into two sets of parentheses, that's what is called factored form. And one thing to notice is that these both equal 0. So basically what we're saying is something times something else equals 0. And what you guys have known from a super young age is that 0 times anything is 0. So basically what we know is that this chunk could equal 0, or this chunk or term could equal 0. Or possibly both could equal 0. So one or the other, possibly both, might be 0 in order to make this thing equal 0. Those two things, or those two terms, are called factors. So this is one factor, and this is another factor. Now, what happens when you get things into factored form is you're going to end up solving these two, and you get that x equals 2. And then you'd solve this one, add 6 to both sides, and you would find that x equals 6. These are right here. These are called the x-intercepts. If you look at this graph, they show up on here, right here at 2 and at 6. It's basically an x-intercept is where it crosses the x-axis. Okay, so when we do this, when we're solving and factoring and all this business, there's a bunch of different terms for these two values, but x-intercepts is one of them. You might also see just a couple other words you can keep your eyes out for, like on ACTs and stuff: roots, solutions, zeros. It's kind of like when you refer to money, you can say like dollars, bucks, I don't know. There's for sure more, like just any way that you can say money is the same idea here. There's a bunch of ways to say the same thing. So if we go back up to the top, factored form is a times x minus p times x minus q. And then p and q are going to be the x-intercepts. So what you'll notice is, never mind, I won't confuse you. You'll start to notice patterns between the factors and then between these actual solutions or x-intercepts. So when you come down here, the FOIL method for multiplying binomials, I'm sure many of you have heard of this, but to multiply two binomials, find the sum of the products of the first terms, so f, the outer terms, o, the inner terms, I, and the last terms, L, which is where FOIL comes from. This looks really complicated, but basically you just take this thing times both parts, and then this thing times both parts. I totally understand that didn't help, but when we start to look at examples, it will make a ton more sense. So down here, this one says write a quadratic equation in standard form. So remember, standard form is this one, this top line right here. So we want it to look something like that, okay? So when we come down here, what they've told us is the roots, remember I said roots is one option, roots are -4 and -3. What that means is they've already solved the factors for 0, and basically what's going to end up happening is we know that x equals -4 and x equals -3 are the solutions. So if we work backwards to try to get a 0 right there and a 0 right there, what we do is add 4, x plus 4 equals 0, and then here we would add 3, x plus 3 equals 0. So what you will see is basically you end up with the opposite. See here it's a -4, and then in the equation it's x plus 4. Here it's a -3, and in the equation it's x plus 3. I'm going to show you guys, there's this FOIL method, but the shortcut is to sorry, I'm trying to choose a color here. If we take x plus 3, x plus 4, and we want them both to equal 0, we can do FOIL, and then I'll show you the shortcut after. So you'd take x times x, which is x squared, x times 4, which is 4x, then deal with the 3. So for the 3, you're going to go 3 times x, which is 3x, and then 3 times 4, which is 12, equals 0 is what that says. 4x and 3x is 7x. So you end up with x squared plus 7x plus 12 equals 0. And there's our standard form. Here's the shortcut. Do you see 3? What's 3 plus 4? 7. And then what is 3 times 4? 3 times 4 is 12. So if you have a standard like this where it's just x a number, you can add them and it gives you the middle term, and multiply them, it gives you the last term. All right, so with the next one, we'll start the same way. So we have the solution is 1/2. The solution is -5. So to make this side 0, first thing we can do is multiply by 2. And you get 2x equals 1. Then subtract 1, and you get 2x minus 1 equals 0. Okay, cool. Got the first factor. Next one, we want 0 here. So the first thing we can do is go plus 5, and you get x plus 5 equals 0. Cool, got the second factor. So now what we're going to do is multiply these two factors, 2x minus 1, x plus 5 equals 0. And then we can do the FOIL method. There's also a box method, you guys. You could ask your teacher. I am happy. That's what I often do. I usually do the box method. You could ask your teacher if neither of these make sense. Like if this method doesn't make sense and the shortcut doesn't make sense, ask about the box method. So 2x times x is 2x squared. 2x times 5 is 10x. Then -1 times x is -x. You can put a 1 in there if you want. And -1 times 5 is -5, or -5. And that equals 0. Then we can combine things. So these guys we can combine. 2x squared plus 9x minus 5 equals 0. This doesn't have quite the same quick shortcut because this 2 out front messes things up. But there is a pattern there as well. If you guys find it, great. So that is our final standard form. Okay, we're going to do these couple, and then this will be the end of the first part. We'll split this into two chunks. So we'll go through this, and then that'll be the end of the video. So in this example, the zero product property states that for any real numbers a and b, if a times b equals 0, then either A is 0 or B is 0. Or both A and B are 0. I already spoke about this on the previous page because that's kind of like what we were doing to figure out those first few equations. But one or the other, or possibly both, should equal 0. So x plus 3 times x minus 5 equals 0. Then that means either x plus 3 equals 0 or x minus 5 equals 0. And then that's when we would solve and figure out what the x value would have to be. Okay, so here is here's the first example. It says factor this trinomial. So basically what we're going to look for, this is the shortcut that I was talking about. We're going to kind of work in reverse. I want you guys to look at this number and then this number. So if the green number is negative 15, what we're looking for is numbers that multiply to negative 15. I'm going to list them. You guys don't have to do this, but just for you guys to see what I'm talking about. 1 and negative 15 multiply to negative 15. Also negative 1 and positive 15. Negative 3 and 5, as well as 3 and negative 5. So the next question, that's it. That's all that would multiply. The next question is, which of those is going to add to negative 2? So we're trying to make them multiply to the last number and then add to the middle number. So of those options, which one adds to negative 2? That would be this guy right here. So what we end up doing is we go x plus 3 times x minus 5 equals 0. Then we can set both of those parts equal to 0. And solve. So minus 3, x equals negative 3, plus 5, x equals positive 5. It ends up being the opposite of whatever it is in the parentheses. So that means that it says solve, which means you're looking for the solution, which again, back here on the first page, I mentioned solutions is something they might ask for. So if it says solve, that means, again, find the x-intercepts or find the zeros. Okay? I'm going to pause this. I'm going to stop this video and give you guys a second to try this one by yourself. And I'm going to start up a new video because this one's just getting a little bit long.